Welcome, and thanks for signing up to listen my presentation on how adhesive technology supports key trends in the Turkish hygiene market. My name is Selda Akbasli, and I am the Hygiene Sales Manager at H.B. Fuller, the market leader for hygiene adhesives in Turkey. In the next 20 minutes, I will cover key hygiene trends. How to test core integrity. We'll look at the market study of a Turkish diaper. We'll explore how to optimize thinner core design. And importantly, how to improve comfort and fit. So let's begin by looking at the key trends in today's hygiene market. Today we see a number of global trends in the absorbent products market, and many of these trends can impact product design, profitability, consumer experience, and day-to-day line operations. We are all familiar with the thinner core trend for comfort and discretion. Now that thin is in, this means higher SAP content for more absorbency. As manufacturers move to thinner products, it brings softer substrates. Consumers today are looking for improved fit and comfort, so this typically means adding more stretch. And while stretch features, such as elastic side panels, are well developed in Western Europe, this is still a growing trend in Turkey, particularly for export business. Let's now look at cost optimization. As increased competition and the battle for market share intensifies, producers are looking to further drive out costs. Thinner products enable more products to be tightly packed, so increasing shelf space for the brand owners. They also optimize transportation and warehouse costs. Moreover, new lines are running at higher speeds to also drive higher line efficiencies. So, we have just been talking about thinner core trends. So now let's look at the qualities of a thinner core. Well, a thinner core has a lower fluff, higher SAP, improved fluid handling, and has more permeability and higher retention. Now we have just mentioned the word fluff. So let's answer another important question. What is the challenge of fluff core versus thin? The fluff in a core has some functions that must be considered. Fluff creates a porous wicking structure that promotes fast liquid uptake and penetration. As gravitational force moves SAP particles, we find it needs to be fixed in a fiber matrix, and fluff prevents the mobility of SAP in that matrix. Plus, fluff can hide hard SAP particles to bring more softness. Due to these functions of fluff, thinner cores experience a number of challenges. Namely, it can get separated much more easily, and it causes potential leaks and reduced fluid retention. Now we appreciate the challenges. How can the core stability of a diaper be measured? Measuring the core stability of a diaper under lab conditions can also be a challenge. Whenever fluff pulp is involved, it's not always possible to obtain accurate bone strength values. But at H.B. Fuller, we were able to gain some relative information about core integrity using our lab equipment. Wet diaper samples were dropped from defined heights with a certain frequency. These tests run until a full crack over the length of the core was visible, and the number of cycles before breakage of the core was recorded. This core integrity test worked out tendencies and gave valuable indications when consistent core with comparable parameters were directly evaluated. We used this test method to compare the core performance across different baby diapers in the Turkish market. So, what are the tendencies of Turkish market diapers? Using 11 different diapers from various manufacturers gathered from the Turkish local market and under the same test conditions, we measured and compared the core performances of each diaper. As you see in the graph, the core integrity performance of each diaper varied. The first few samples from A to E demonstrated a low average numbers of cycles before the breakage of the core, while H to K showed a significant higher integrity. The core stayed in a place longer and gave a higher stability when wet. But these results are not surprising for two reasons. One, with today's different diaper designs, this graphical distribution is typical. Two, there are a number of parameters in the construction of a core that can influence the core integrity of the wet diaper. So, what about absorbent parameters? Parameters influencing the strength of a fluff core are fiber length and fiber entanglement of the fluff pulp. Longer fibers and a higher entanglement may lead to better stabilization. A higher compression of the fluff core leads to a higher pad density and a more stable core. If the SAP is well distributed in the core, the fluff can work as a buffer for the swelling SAP particles when wet. And if a high amount of SAP particles is located only in one place in the core, there is a potential area for the breakage of the wet core. Additionally, the more tightly the fluff core is fixed, the better, as the stability is better. A core that is well wrapped in a C-folded nonwoven is more stable compared to those that have loose parts in the surrounding substrate. The acquisition distribution layer on top of the core must help to distribute the insult over the entire length of the core, because if the liquid remains in one area of the fluff core, this would be a potential area for breakage of the wet core. And last but not least, the adhesion of the fluff core to the surrounding substrate is essential. This adhesive must hold the wet core in place, and so for core integrity should be considered very carefully. So we have learned a great deal so far. Let's recap. We have learned about hygiene trends, the qualities of a thinner core, the challenges of fluff core versus thin, how to measure the core stability of diapers, the tendencies of Turkish market diaper, and the absorbent core parameters. Now you are ready for the technical details. Basically, there are two different types of technology that can be used for the core. One, a diaper manufacturer applies a standard construction adhesive to fix the fluff core. Or two, a diaper manufacturer uses a specialty core adhesive in the core area. A standard construction adhesive is typically fast-setting and leads to a more superficial bonding with minimal penetration. It sits more on top of the substrate surface, as you can clearly see in the left image. However, the flow properties of a specialty core adhesive are designed to allow for a deeper penetration into fibrous substrate. This is based on a delayed crystallization effect of the adhesive formulation. It allows the adhesive to flow and fix a great number of fibers before it reaches the final bond strength. This leads to an excellent mechanical anchoring of the laminated substrate and provides a high wet strength. You can see the effect in the right image. More specifically, here is an example of a medium-sized baby diaper where the fluff core was enclosed in two nonwoven layers, one from the top and one from the bottom. On each nonwoven, 2 GSM adhesive was applied. So in total, 4 GSM adhesive is in contact with the fluff core. The direct comparison of the very same diaper design shows a clear advantage of the specialty core adhesive over the standard construction adhesive. Specifically, a higher average number of cycles before breakage of the core in the lab test was recorded. Further evidence can be seen here. These images show the importance of core wrapping substrates. Whether these are core wrap nonwovens, tissues, or top sheet and back sheet. With specialty core adhesives, under dry and wet conditions, these substrates are adhered to the core. With construction adhesive, you can see that as soon as there was any disruption, the core failed and almost no fluff stuck to the top layer anymore. As you may know, the thickest part in a diaper is the absorbent core. So if a diaper should be made thinner, we must consider the core design. So what is a typical core? The core typically consists of fluff pulp plus SAP, which absorbs, distributes, and holds the fluid to prevent leakage until the diaper can be changed. An acquisition distribution layer sits on top of the core to help wick the moisture away from the weaver and distribute it to the core quickly and efficiently. In modern baby diapers, the core is wrapped in nonwoven or even sometimes tissue. This could simply be a layer on top and bottom of the core. Adhesive is applied on these nonwovens to fix the core. With many diapers today, the nonwoven layers overlap at the sides and are laminated together so that the core is enclosed. Some diaper manufacturers even worked with so-called C-fold core wrap, which means that the nonwoven is wrapped around the entire core. However, most adult incontinence diapers are structured more simply and have the fluff core directly between the top sheet and the back sheet substrate. Now we know what a typical core is. Let's explore the impact of two application methods. The first one being adhesive applied to wrap nonwoven. In diaper production, this absorbent core consisting of fluff pulp and SAP is preformed in the hammer mill and then placed into the diaper body. And as we've just learned, the typical way in modern baby diaper production is to wrap the fluff core in nonwoven or even sometimes tissue before it's cut and placed between the back sheet, acquisition distribution layer, and top sheet. Adhesive that is applied on the upper and lower wrap nonwoven to hold the core in place is either done via non-contact spray or contact slot coat applications. Often, as these nonwovens are quite thin, spray with low air pressure is preferred, as it leaves most of the adhesive on the surface to penetrate and fix the fluff core. And interestingly, for slot coat applications, it turns out that it's optimal to apply the adhesive as a stripe pattern created by a comb shim in the slot nozzle, rather than a full distribution of the adhesive over the whole width of the application, because by applying stripes on the nonwoven, the adhesive can fix more fibers of the fluff core. The second application method is adhesive applied directly on the core. As we now know, depending on the article configuration and the target, the core adhesive can be sprayed directly on the core with minimum air pressure. This can be done via an additional spray application, or as an alternative, you could apply the adhesive on the upper nonwoven. The added benefit of applying the adhesive direction on the core is that it can help improve the core integrity. Why? Because the adhesive can penetrate the core really well and fix the maximum number of fibers. Now we have covered the two different application methods. Let's follow this by comparing how the core integrity is influenced by these different application technologies. Here you can see an example of a medium-sized baby diaper, where the fluff core was enclosed in two nonwoven layers, one from the top and one from the bottom. On each nonwoven, 2 GSM adhesive was applied. So in total, 4 GSM adhesive is in contact with the fluff core. The direct comparison of the very same diaper design showed an advantage when the adhesive was sprayed directly on the core compared to being applied to the wrapped nonwoven. Specifically, a higher average number of cycles before breakage of the core in the lab test was recorded. So what's next? Well, having learned what the influences both of the adhesive and the application can have on the core integrity of a medium-sized baby diaper, let's now return to the concept of making thinner diapers. The impact of the SAP and fluff ratio on the core integrity was tested on a consistent medium-sized baby diaper design. The fluff core was enclosed in two nonwoven layers, one from the top and one from the bottom. 3 GSM construction adhesive was applied and was the total amount in contact with the fluff core. As a variable parameter, different SAP fluff ratios in the core of the diaper were tested. Looking at the green bars, you see the results. Reducing the fluff content over a 50-50 to a core with a 60-40 SAP and fluff ratio leads to a decreasing average number of cycles before breakage of the core in the lab tests. The orange bar shows what happens when the same fluff reduced cores were bonded with a special core adhesive instead. As you can see, there's a similar correlation between the fluff content and the core stability. However, the core integrity is on a higher level compared to the cores fixed with a typical construction adhesive. In this respect, it's proven that a specialty core adhesive allows for a reduction of cellulose in core, which brings potential for cost savings. It also gives the opportunity to shift from nonwoven to a less expensive tissue. It can increase consumer satisfaction with maximum comfort and discretion. It can improve core integrity with minimum leakage, and eventually it could decrease the total cost in use versus traditional cores. Right from the start of this presentation, we have learned about the importance of consumers of both comfort and fit. To answer this call, manufacturers are adding more stretchable parts into modern diapers. So it makes sense that we take a little time out to explore stretch market trends. A study of baby diapers in Turkey indicated 47% have a form of elastic side panels or stretch ears. This compares to around 90% in Western Europe. This ratio is likely to increase in 2016 as typical consumers demand an improved fit. And as stretch features are now appearing across more lower product tiers in Turkey and its surrounding export market, we believe this figure could increase from 47% to 60%. So, in this frame of mind, we suggest you consider an adhesive online solution for tape and elastic side panel attachments. We suggest you apply the adhesive online for assembling the fastening system of diapers. Why? Because it increases tape bond strength. Online application can save you money. It provides flexibility in choosing tape and elastic side panel material. And it creates an alternative to pre-assembled wire bond tapes. At H.B. Fuller, we provide an online solution with our family of full hook adhesives. Our full hook adhesives are designed to deliver superior performance and value in hook and loop fastening systems. They enable manufacturers to gain total control of tape assembly and reduce manufacturing costs. Simply put, you can gain flexibility in tape material selection. You can achieve higher shear strength. Why not find out more on our website today? So now we've reached the end of my presentation. Let's take a final moment to recap. In summary, we have covered a number of topics, including the different parameters influencing the core integrity, block-reduced cores and its requirements to maintain stability, the impact of adhesives and application methods for a higher core integrity. We have proven that a specialty core adhesive can show an improvement on the core integrity of a medium-sized baby, and predicted how stretch features will grow in the coming years and how adhesive can support this trend. Thank you for listening and finding out how carefully selecting the right adhesive and adhesive partner like H.B. Fuller can help you achieve enhanced core stability. Because with more than 30 years of technology leadership in hygiene markets, we know what matters to customers. Enhancing comfort with softer substrate, creating thinner, more discreet products. You can rest assured with our full care solutions.